We're solving problem 22 from the 2021 F equals ma. A ship rams into a hunk of floating ice in the sea. Icebreakers are ships designed so that when this happens, the ice is pushed down beneath the ship. If the coefficient of static friction between the ice and the ship is mu sub s, what condition applies to the angle theta as shown in the figure so that the icebreaker functions as intended? So at this point, here's our ship, and then here's our ice or our iceberg, and there's gonna be forces acting on it when it's at the instantaneous moment where the ship approaches the ice. There's gonna be the normal force, and of course we can rewrite the angle theta to meet the requirements for this. It's where F is like the force going up, and N is the normal force pushing back up. So for this problem, we can equate, or we can write a system of equations of some sorts where we can write that N times cosine of theta, since you can make triangles with these angles and lines that you draw, is gonna have to be greater than the maximum force F times sine of theta. Why? Because we want the icebreaker to function as intended, and we want the ice to be pushed down the ship. If this was greater than n cosine theta, then the ice would be pushed up, but we want that it's not pushed up. And F maximum force times sine of theta is equal to mu of s, the static friction coefficient, times n times sine of theta. You can cross these out, and then you get that when you divide both sides by sine of theta, cotangent of theta is greater than mu of s, which is exactly the answer we want for this problem, and is answer choice A in the answer choices.